All right, welcome back, hackers. This week you might have already seen the topic based on the homework assignment that was released on Monday, but this week's topic of choice is web hacking and web penetration testing.
A few announcements about the assignment.
Yeah.
Just to get out of the way. This assignment and all the assignments from now on will be a week and a half long. So it's been assigned. It was assigned yesterday, and it'll be due next Wednesday midnight. So not this week's Wednesday, but next Wednesday, which is May 6th at midnight. And so just keep that in mind as you do the assignments. I think that was it. That was also all we have to talk about.
Is there another announcement, Ethan? Is there another announcement you wanted to make?
Let me double check whether I see this true. Yeah, AI content is not allowed. Don't use AI in your submissions. Don't use them to solve challenges. Yeah, just trying to avoid using AI. Not that you could be able to do becoming assignments. And please stay in scope. OSINT challenge is not hacking anything, so it's all passive. The other two must be connected to our VPN and only hack and only target the IP that we gave you. Don't go out of scope.
All right. I don't know if that got picked up on the recording, but the reminders was our AI policy has been made very clear in the syllabus and in the assignments. No AI content is allowed on any of the assignments, period. Stay in scope during the assignments. The upcoming assignment will be pen testing stuff, so I think it's a little, just follow the instructions as they were given. If you would like any clarifications, feel free to reach out to us publicly or privately at any time. Okay, with that covered, let's talk about web applications. So, what are we going to be doing today? Well, first, in order to attack web applications, we must understand web applications. So, I want to take you a little behind the scenes for what goes on when you access a website, just any website from like example.com to like Google. And from there, we're going to discuss what are the different parts of a web application, how they interact. Because understanding the parts of a web application, how they interact, will lead us to what kind of vulnerabilities exist in those systems. And I emphasize the word systems because as much as web application, code is usually, you think of code as just single programs. Web applications are typically complex systems of multiple programs interacting, and the ways that they interact, we can figure out ways to target. Talk about vulnerabilities. Some vulnerabilities will continue. I'll do a more in-depth discussion on Thursday, but right now it's just more theory, conceptual, get you started type stuff. Vulnerabilities and what kind of tools we use. And while I'm talking about the different tools we're going to be using, we're going to be doing some challenges and to get you acquainted with these tools live. Any questions before we get started? All right, let's roll. Okay. What is a web application exactly? So figure this out. Let's talk about, just see what happens when we connect to a website. So what I'm going to do is I'm going to pull up ye old friend Wireshark. If you want to, that's not Wireshark. Wireshark. Let's take a look at it from the network level, right? Let's see, capture everything that goes on theoretically when I say I want to go to the website http://example.com. Okay, the website has been loaded, and I think we'd stop the capture. Whole lot of data in here, but I'm just going to capture specifically the web stuff. So I'm going to say http, give me this. Good. Huh? I'm just demonstrating for now. Hold up. Did it get captured? Okay, it didn't get captured. Let me try an incognito tab and force it to load the page. Capture, continue without saving. Okay, just loading sample.com. It's weird. It worked on my home Wi-Fi. I don't know why Eduroam does not like this. Okay, that's kind of awkward. TCP. Yeah, there's this data. Wait. Oh, I trolled myself. I said HTTPS. I want specifically HTTP. Sorry. One more try. Continue without saving. I want HTTP. Do not.
It's too secure.
It's too secure. Yeah, exactly.
Open up Internet Explorer now. Probably put in the forever HTTP site.
Yeah. Then I'll use the alternative I had. It said Mac FE HTTP. Yeah, I had a. Let me see. Check my notes. See which one. Oh, testing McAfee sites.com. Mac testing. Sorry, give me a second to find it. www.testingmcafeesites.com. There we go. Okay. Okay, there, the data loaded. Let's start breaking down and seeing what happens when you load a web page. I mean, is everyone here familiar with HTML? Or actually, anyone here not familiar with what HTML is? Sure, I'll briefly describe it. HTML is just kind of the source quote, what source code is for a website. It just describes how the web page should be laid out. You see, like, you have a head, you have a body, you enclose what you want displayed inside these tags. That it just essentially just lays out, tells your browser how to render the site using these instructions. I mean, you see, like, here's a link. I think the A tag is how they specify, like, this is a link and whatnot. Paragraphs is P, and so on. Okay, but how does your computer exactly grab the source code from the web page? And you can see that if we look through some of the data over here, I mean, oops, I think I scrolled. I mean, if you like click through some of these pages, you might resources not available. You see a lot of data. Some point, I think if I reload the page, it will display the source code at some point. But you can see some commonalities in all the data that we've gotten so far. You've seen that it's some kind of request protocol called hypertext transfer protocol. And I guess if the zoom is large enough, you might see that, if you click on a page, I just went to McAfee.com, nothing at the end, and it seems like it grabbed slash. If I continue capturing, if I go to testcatal.html, looks like I put in a request for that page.html, and it seems to return, oh yeah, it returns the exact source code. Okay, so there's something going around behind the scenes. There's making requests, it's calling a page, and it's some kind, and from there it's returning the HTML code. Let's break down HTTP protocol. I guess, or actually, tell me. Looks like I've already spoiled it, so I'm just going to move on from this exercise. So this is what the HTTP request looks like. Every time your computer wants to go to a web page, this is how it's pulling the data from the website. HTTPS, I had a little trouble reading it earlier. It's encrypted, but know that the actual thing that it's retrieving, it's still this entire quote request. You can break the request down into kind of 3-ish parts. You might not always get a body, but you can guarantee for every request there's probably a request line and maybe some headers. What does request look like? Well, looks like there's some text in all capitals. We saw get earlier. This one has a post. And then afterwards, it's like maybe that looks to be that specific thing we're trying to get. Like, oh, this is getting users, or when we get testcat_al.html seems to have that there. HTTP, some kind of protocol, okay, it works. And some headers. Looks to be, it tells who's getting it, host, etc. So HTTP request is how you specify what you exactly want to get. Let me just pull it up. The most common HTTP requests are always going to be get and post. Get, kind of self-explanatory. I want to get a web page. Give me it. Post, you see that this one has a little bit of body. Anyone guess what post is intended to do beyond just getting data? There's a body in there that you're sending to the server.
Sending data to this form.
Yeah, you're sending data back to server. So, your server, web server, maybe you want information like, say, I want to register for an account. How do you send that data from the website to the server? You put in something like post request, and then there's like a whole bunch of other request types that are related. I'll talk about APIs in a bit, but 99% of the time, and I think all you need for the assignments, most importantly, is just know that you can retrieve things with get, and if you want to send data, you want to use post. And of course, and then you include headers and some body. A really nice thing about HTTP is that it's entirely text-based. It's not like, if you've taken something like networks or some other class, it's like, I have to worry about, I need to send a 32-byte integer, and if I set like the 15th bit, it indicates that I'm making this kind of request, that kind of request. HTTP is really simplistic. It's just strings. You send a string to a web server, and then it should send back whatever you want. Okay, any questions about this so far? Pretty much text-based protocol. You get stuff, and there are different methods of getting stuff. Okay, that's HTTP. Now, let's just take the example for a GET request. GET request, you pull it down, you get some HTML code. But HTML code is just, it's just this stuff. Or let's go back to, this is not formatted very well, so I'll just say like, all you retrieve with this, if you've done any kind of work with websites, you know that, you can also include little JavaScript stuff. But past that, you're kind of limited. I mean, you can do some funny tricks with like HTML and CSS and make it do, make images do like backflips and whatnot. But past just like rendering things, you're kind of limited. So this brings in the kind of idea of what is a backend. Say you have some kind of application that, it's not just about rendering. Say you're on YouTube. You need to say, I want to grab the video and play it on YouTube server. It's not exact. You can't do that with just the web page. Or think of another example. I would say, LLMs. You're not exactly running Claude or ChatGPT or Ollama or name language model choice here on your computer. So you're running it on OpenAI's server or insert company here, servers. How do you get that data from, that data is not being generated by HTML code live. So you need some kind of way to communicate between the HTML code that's running on your browser and whatever is running on a web application's web server. Because at the end of the day, all your browser does is take HTML code, take JavaScript, maybe WebAssembly or whatever technology if you're feeling ambitious. All it does is just render code. But if you needed to do more complex operations, you're going to need a backend. And, with a backend, you need a way to pass data from your web page to backend. Any idea how you would pass data to a backend? We were discussing it like 5 seconds previous.
HTTP requests?
Yeah, HTTP requests. We just use post, send some data from a web page to a backend. Okay. So from here, backend, we can talk about APIs. So programs are, notoriously picky about how data is formatted. If you send data that's like not formatted correctly, your computer will literally explode and burn down and whatnot. So you have to define a set of rules of, hey, I'm expecting data in this format. I want to, my backend is expecting data in this format. How do you exactly do that? And this is what we call, this is where we bring in the idea of APIs. APIs are just specifications for how to send HTTP data. It's just like, oh, what kind of body, you have this body could be anything, but with an API defines, I have to put first name, last name, email. Oh, this is optional, this is necessary. Kind of the rules necessary to interact with an API. And I'd like to say that even though you can use post requests, it's one way of passing data between your website, your quote front end and a back end. There's a lot of different ways to do it. So actually, I'm going to spin up a quick demo that I cooked up. Yes, this one. Compose up. Post 5,000. Yeah, this is a bit of a quick web server that I cooked up with AI. Full disclosure, but different ways. I'll show you different ways to pass data to an application. So once again, we will pull up Wireshark and capture exactly how to capture data. So I will say everything's happening on localhost. Area connection. Give me loopback. Okay, so just a brief overview of what this app is going to do. This is going to quote send data to a quote backend. Both front end and back end are sitting on my local computer, so I'm just sending data to myself, trying to mimic the ways I can send data from a front end to a back end. Just getting into the weeds a little bit, but there are 4 ways to do this. Post is not the only, so you know what? I'm just going to capturing data. 1, 2, 3, 4. Okay. So we already saw you can use post to send data to an application. You probably saw that in the earlier example. You might recognize this as something that is in JSON format. It does not stand for JSON long format. It stands for JavaScript Object Notation. It's just a way of enclosing data to say like left brace, right brace. Here's a key, colon, value. Way of storing data that can be easily handled by web servers. That's one way of sending data. We can see that JSON. I sent a request. This does a little too good of a job at capturing what is being sent. But I guess if we zoom post, oh, I know, follow this. Next, see, bop, bop. I want to send it in this format. There we go. See that we sent data to a server using a post request, and we just embed the data in the request as this. This is kind of JSON. Everyone kind of understand that this format without any spaces is the exact same as this. On Gucci? All right. One way of sending data. Another way of sending data that's kind of funny is you can actually embed data inside the URL. So say I am banned from making post requests. I cannot send data to a server using post requests. I can only use GET for whatever reason. Is there any way that I can still send data to a server? And the answer is yes. If I just embed that data inside the URL itself, like say instead of saying, oh, get web page, I include like a little extra information at the end, saying like get this page, but with the option, I don't know, yes, no, whatever. That's another way of sending information. Let me just pull it up. There's a way of getting information that say, oh, give me this, go to query string, API query string, but then I add like a question mark equals And then from here, I can include the exact same information, but it's just encoded. Key value separated by and, key value and. Does everyone understand what I mean when I say key value pair? Or is anyone not clear what it meant by key value? Okay.
Are you able to zoom out or Windows magnify?
I mean,
They can read it.
can people in the back see this okay? Or do you need to zoom? No? You need to zoom or? Okay. I don't know if Wireshark supports this, so Windows accessibility. No, I'm kidding. Magnifier. Why is it trying to update? Does this make it a little easier to see? All right, sorry about that. But yeah, this is another way of passing data. If I can't use post, I can say get, and then I can send the data encoded in the URL itself with like question mark. You split it with a question mark, and then you start saying key equals value, separated with an and, key equals value and, key equals value and, whatever. So you can embed data inside the URL. Different ways to format it inside the URL as well. You see that this example, it uses, it just says, instead of using the fancy notation with question marks, let me just define like 5,000, just separate all the information you ever want to pass along using directories. Okay, that's fine. It limits your options a little, but valid option. I'm not here to teach a system design course. I'm just exploring the options available to you. You have JSON, and you have similar. Let's see. Let me boot up the magnifier again. Similar to the bruh. What do I even want? Voice? Okay, whatever. See that it has the exact same format as when you were passing it in the URL, but instead of passing it with a GET request inside the URL itself, you're just passing it as data inside a POST request. You have like data, key value and key value and key value and this very funky %40 email. Anyone want to guess what %40 might be? Close.
Add symbol?
Yes, @ symbol. I'll talk a little about like why you have to use this kind of notation in a bit, but
Is that a hex?
yes, I believe it is 0 hex 40 is the @ symbol. But we'll talk why it has to be encoded this way, as opposed to why can't I just use @ when I send this data? All right. Okay.
Someone said space, right?
Spaces. What is space?
40 is actually space. If you look at it and read it in decimal, you read it in hex, it's at. So that was a good guess.
That's actually, I did not know that. That's pretty cool. Okay. Sending data to a front end and a back end. And I guess I'll just show like what a more quote more realistic API looks like in a bit. Just attach, compose down. I know I cooked this example up in AI in like 5 minutes, but would anyone like this to be made available on the course website? Or do you think is it information that's may not necessarily be needed? Thumbs up, thumbs down. Would you want it to be made available?
It wouldn't harm.
Okay, I'll put it up on the Akhil's lecture repo at some point.
We might use that lecture too.
Well, might as well. Okay. Give me 1, 2, 3. Okay. Back end. Yeah. APIs. Let's show you a little bit of example of how we interact with them. In this case, localhost 8000 docs. So this is, I guess, just like what is going on here. This is for like a random class project I did last quarter. I made a very funny alarm app that you could essentially internet-enabled alarm app in sense. And what are the data requirements for an internet-enabled alarm app? Well, you need something to you need to save information about wake ups, and you need a way to create, delete them, whatnot. So how would you interact with these? Well, generate an HTTP request, and then from there it would modify the data. So let's see. For example, get wake ups. List the wake ups that are already there. See a request URL. Curl is a tool we use to interact with APIs, but in this case, 0. Okay. I want to use a post request to create a new wake up. So I'm just let's see, try it out. 500. Execute. Internal server error. I'm trying to remember how I use this. Give me a second. I think it's like a random number. Trying to remember how to use this, but in a nutshell, you use this to interact. There is some piece of software running on my computer. You interact it with HTTP requests, and you can use it to change the state of an application when normally HTML code and JavaScript won't be able to have all the functionality. I'm just gonna move on because I want to leave time for the other things. String is not a valid URL. Oh, actually, name a YouTube video.
Rickroll.
Okay. Give you up. Do I have sound? The first lecture video to get copyright striked. I guess I'll just say sound URL. Good. Why not? Okay, it's creating a wake up. It's executing some instructions in the back end. And then I think I have the data stored in, let me find it. Data backend / data. Project. Sorry about this. Let me just figure out. Backend, I have the data stored here. So see, before there was only ID 0. I just created an ID 1. From there, I just changed the state of the server using HTTP requests. Bit of a long-winded demo, so just shut that down. Any questions about that specifically? Okay. So you saw that I kind of sped through it, but you kind of saw that I was storing all the data about my server in a literal file on my computer. But in reality, web applications, that would never work. Why? Because, for a random project that I do for, I don't want to swear, for poops and giggles, is, I can get away with using something simple like, oh, let me store all the information about my application in like a random data.txt file. But in reality, that's not going to work for YouTube. That's not going to work with Google. That's not going to work for any application that expects to have, I don't know, number of users greater than, I guess, 100. Ideally, when you're building a real web application, you want to be able to have some kind of storage method that can support something like, oh, I need to have millions of operations per second, and they can't run into race conditions. They have to handle data safely. Things can't go wrong. So when you're storing data in a web application, you're using some kind of database software. Most common is something called SQL. Everyone here heard the name before? SQL sound familiar? Yeah. SQL. There's also stuff like Amazon buckets and whatnot, but I'm not going to cover about that. These are just, for web servers, you need something like front end, back end, and the back end needs a piece of database software. So what I have just described is the full stack. You've probably heard a jillion billion times the phrase full stack developer. Before AI developer, this was the hottest thing on the computer science market. What full stack means is you're able to handle all the technology, all the software, you're able to work with it to build a fully functional web application, not just like graphic design in a web page, not just like some API in the back end that handles whatever you need your web application to run, not just like manage a database. You're able to deal with all of the applications needed to run a web application. Example of like quote everything you need to run a web application is what's known as a quote LAMP stack. When we say stack, we mean just like the specific groups of software that you need to assemble a fully functional application. LAMP in this case is like a fun open source, anyone can run it. That involves Linux, run a Linux server that's running Apache web server, a MySQL database, and then whatever fun programs you run on the back end, you can code it in PHP, Perl, or Python. This is kind of the full stack of what full stack development is. So why has all of this information that I spattered you about web development that normally should have been taught by Tai Feng, but bless his heart, he's not here anymore. Why was all of this information presented? Well, each of these components depend on each other. If you take away a database from a WordPress application, it will explode. You will not be able to use a web page. They don't just depend on each other. Well, they depend on each other and they need to interact with each other. All of these separate components can have vulnerabilities that we can exploit to our advantage, and the way these components interact can also be a source of vulnerabilities. Understanding that web applications are not just some kind of static black box, but a system. They're separate components that can each be targeted or attacked together. It's critical to understanding how web application security works. Okay, that's enough theory yapping. Anyone have? I've asked this like once every 5 minutes, but anyone have questions about everything so far? No questions? Give me a temperature check. Anyone so confused they don't know what to ask? Gotta ask that at least once. Okay. All right. Let's get into the fun stuff. Let's talk about tools you'll need in your toolbox to do web pen testing. The first one and the most obvious one is one that you have installed already. This is your browser. Browser, DevTools, Control-U, look at source code. Pretty good first pass for any web penetration testing challenge. What I'll do is I'll start off with this first one, Challenge 66. Don't use client-side. Can you break into the super secure portal? I'm actually going to give, we're doing pretty good on time. I'm going to give, let's say, 8 minutes for everyone to pull this up and see if you want to take a stab at it. It can be solved with just your browser. So I encourage you to take a stab at a challenge. I'm going to set a timer for 8 minutes. We'll reconvene at like 25:26. All right. Happy hacking. I will say a couple tips I have is when you're presented with any sort of process or kind of thing that a web application is doing, always remember to ask the question, how does it work? Where is the code that controls this process? And always, poke around and make sure you check, quote, everything. All right. All right. Don't use client side. How to start the challenge is you hit launch instance, and then I think it'll pop up a URL that you can open and start poking around at. Yeah. Control C, Control V, and have fun. feel free to work with your neighbor. I don't know. The silence is giving me bad vibes. Okay, good. Just checking in. Any just like doing a quick check-in on how progress is. Has anyone figured out an approach? Anyone get any progress? Feel like they've gotten any progress?
I build a JavaScript. It's just a long statement. How do you interpret a long statement?
Anyone feeling stuck or okay? Give a yeah.
I believe it's all with your browser is first one.
Both of them should be. We're just working through it. If you'd like to work on the second one, I feel free. But yeah, both of them can be solved through the browser. Bless.
What is the second challenge number?
Second one, I think this it's on the slides, but yeah, I think 46. Yeah. Second one is called login. I all the challenges I think they're in the links are in the slides, and I think I've linked them all on the lecture notes page already. If it's not, let me know. Anyone else been able to solve the challenge in the meantime? Give me a thumbs up if you're able to solve it or at least have a path forward. And we're like maybe like 50%. Okay. All right, okay, it's been a couple of minutes. I'm going to bring everyone back in. Okay. I'm just gonna open this up. Okay. All right. Okay. I know I just asked this. Raise your hand if you're able to find the flag and solve it. Okay, that's pretty good. All right. Just start shouting out what should I look at?
First, inspect the index.html.
Okay, inspect it. In this case, I'm just gonna inspect. What do I like? I'm just gonna refresh and do this. Okay. Actually, I guess you were asking to look at the source code.
Yeah.
Okay, that's probably easier to. Okay, what should Okay, what's so notable about what's going on?
There's Pico right there.
That's true. Pico CDF. I mean, yeah, it is kind of a dead giveaway just by right there, but essentially what the code describes is if you hit the verify button, it runs this function, and then if whatever you put in, if it matches this mildly obfuscated, but it's not that hard to decode string, you'll be able to retrieve the original password. So I'm just gonna painstakingly put it together from scratch. So go cyber chef. I'm just gonna do it by hand. I'm sure there's go. Yes. Okay. Pico 0 split to 2. It's being very CF 2 to 3. 3 to 4. 4 5 5 to 6. 6 to 7. All right, you can let it out. You can laugh. You're allowed. 6 7. All right. Sorry. Okay. I believe that is the entire flag, and if I put it in here. All right. Excellent. We've solved the challenge. Okay. The challenge was called no client side, don't use client side, and using a form of authentication called client side authentication. What was the problem of client side authentication? What's the issue here?
They're given access to the source code so they can see like how you're checking things.
Yeah, exactly. You see the source code, you can just, I mean, it's like it's like doing if password equals password, return true. If you have the source code for how to do the authentication, I mean, it's not going to take very long for an attacker to get it. I mean, even in the harder example, I'm not going to, let's see, there's another client-side challenge that I'm not going to try and solve entirely, but it's the same principles. Let's see, I think the main, let's see, yeah, new and improved login, and they were using verify JavaScript. They were using this, so let me just do let me see if I can just open it up. This very funny looking piece of JavaScript code. Is there any way I can HTML, give me raw. Think there's a way to make it look nicer. But I mean, you see here, there's like a very long piece of code that I mean, they very helpfully for you took. I don't know if it's that visible, so let me just Control plus. They very helpfully for you took out all the function names and replaced them with stuff like, this is a bit of a reverse engineering challenge. You have some JavaScript code and you're trying to figure out what the password is. But the issue is not that they didn't hide it hard enough. The issue is that you have the source code. And from there, it's not, it'll take you, it'll be a little harder, but it's not going to stop attackers completely. All right. Stop this instance. Okay. Here's a second challenge that you can solve from your browser. I'm going to just walk through it myself in the interest of time, just show you what, I guess, how I would approach one of these challenges and think through it. Okay. So here's I mean, I might as well. They give the hints are free, so I might as well. Can you log in as Joe and find what they've been looking at? Okay. Joe, I don't know what the password is. I'm gonna say password. Joe's password is super secure. You're not getting in that way. I'm just gonna try random credentials and see. Okay, factory login. You've logged in. Not sure you'll be able to see the flag though. So for me, this raises a couple suspicions. I can log in as any random set of like user credentials. I can just, I mean, if I just do, and like, I'll be able to log in. So seems that there's nothing that's really authenticating. There's no like username password check. So that makes me want to look at the source code. Always investigate all the leads. Some of the stuff in the source code is just default formatting. I mean, Bootstrap, jQuery, Jumbotron, Bootstrap. That's just like formatting things. This looks to be just fun stuff. Alert, no flag for you. Okay, but this is after I log in. What does the login screen look like? What am I? And here's a funny thing you can do with dev tools is that you can capture requests of like when I say I want to execute a login, what information is being sent out over HTTP that does the login for me. So I mean I'm just gonna do like test. I mean it made a request over post. I mean, response. I mean, I sent form data response. There's no response, but what's really interesting is this kind of cookies thing. It seems that in response, they use cookies. Interesting. I mean, I don't know if it's a little hard to read, but I mean, from this, what can we infer about what the authentication process looks like? How are they authenticating their users? I don't know if I can.
Authenticate them to what the cookie set.
Say again?
To the cookie set.
Yeah, they set so logging in. They're setting the cookies. They have a. I put test user. Okay, yeah, this is hard to read, but username. I log in with test value test password test, and there's a very funky one called admin value false. What's the logical next step? Admin value. Admin value to true. All right, let's give this a shot. And you can actually, I'm just gonna log in. So if this is Firefox specific, but in DevTools there's a not memory. This there should be a place called storage, and from there you can like tinker with cookies. Because, cookies are just bits of data that are stored in your browser. I mean, no one is not like, this cookie cannot be changed. No, it's just a piece of data. It's like, what if I just change the file? Sorry, this is not the output. Let me zoom out. Oh, yeah, I zoomed in too far. Admin true. All I have to do is refresh the page. That's it. That is the challenge. So authentication, I mean, I think in most cases, they're not going to be like, oh, let's have nothing in the backend that validates users. Let's store everything with cookies. But cookies are a valuable way of storing are you logged in or not. We'll investigate them more on Thursday, but something to think about. All right. Is this still running? I thought I solved it. Okay. So just browser dev tools are really nice, but they don't really cover all the use cases for web pen testing. And you know what? I'm going to do let's see. Actually, this one might be a bit more appropriate for what's going on. Okay, this challenge. We're in the middle of an investigation. A sensitive person has put data portal. There's a login email address. We don't know the password, but feels like the developer left a secret way in. Can we figure it out? Okay, let's launch the instance and figure it out. So clues are we can't exactly use password, but there might be something backdoor adjacent. And to do that, let's take a look at the source code yet again. What does the login process look like? Well, okay, this is information. Very, very funny looking comment over here. But let's just see if they made the mistake of doing client-side authentication. Looks like the form has a script, and then once you have the data, once you hit submit, it looks like they pull email and password, and they push it to something on the backend. They make a post request to the backend. We don't know what kind of code they're using to log in, so it's hidden from us. That's the way things quote should be done. But this looks really interesting. This remove before pushing to production. It looks some kind of encryption or cipher. All right. Anyone want to throw out guesses for what kind of cipher it could be? Sorry, one guy, you're banned from this after. Yeah. Anyone want to guess what kind of cipher we want to try at this to try and decode it?
Base 64.
Base 64? Let's try. From base 64. Doesn't look like that so far, but it does look like, I mean, base 64, it doesn't have the equal signs at the end. Maybe it's not. But it does look like these look like words and spaces. This could be, let me just throw it at base 64. If it was base 64, it'd probably be like long string of stuff, but there's spaces and things that look like it could be words. So what other ideas do we want to try?
Is this the user cipher?
Okay, let's give it a try. Caesar cipher. ROT13. In this case, ROT13 is a variation of Caesar cipher which rotates at 13 times. There's 26 letters. It's quote symmetric. I hope you remember your cryptography. But okay, it looks like we're able to decrypt it with Caesar cipher, and it looks like, notice, temporary bypass. Use header xdev access equals yes. Okay, so this is a callback to the HTTP request. HTTP request, we make a request and request headers. So it seems like if we just include the header xdev access yes in the request, we'll be able to get it. That's probably what we're supposed to do. So let's try doing with the browser tools. Let me just do a network. I don't know. I'm just do like test at test.com, bogus, invalid credentials. Let me just all. Makes a request. Okay. Oops. There's a bit difficulty here. I really want to modify this request and send it again. I want to cook up my own request and send it. But DevTools is not exactly built for sending your own requests. You need some other tools to kind of build your own system, build your own custom requests, and send it. Not going to be just usable.
I see that there's a console. There's a console.
There's a what?
There's a console.
Honestly, I think you can. I'm not too experienced with using the JavaScript console. I would, if you're able to, I think, if you just Google send custom requests via browser console, it would work. But I'm going to use something that's like much more designed specifically for security usage. And this is a tool called Burp Suite. Burp Suite is, quote, industry standard tool for web penetration testing. Okay, on your Kali boxes, do you want to, I don't think it's installed by default, but you are able to install packages. Would you like me to install them for you, or would you be comfortable doing yourself? Please save me the work. It's one command. It's one command. Thumbs up, thumbs down. Yes, install it for us. No, don't install it for us. I'm seeing like no, so I guess you will need to, if you want to install it, the package is called, let's see, Kali Burp Suite package. You just run sudo app install.
Instead of installing it, you can just basically either give us the hint that we need it exactly there or not, or just like give us the command as part of the document. That'll save you the whole work.
Okay.
Suite is not required for Homework 3. Yeah, I'm just saying if we need it, then you just.
Yeah, you won't need it. It's more if you want to try it on your own. Then,
Okay.
Yeah.
Yeah, I'll use it because it first steps into using a much bigger tool, and also it is pretty helpful to use. So okay, so let's do a request. Let's this is how Burp Suite works. It doesn't use your own browser. It has kind of its own browser that you can do stuff and intercept requests. So let me just target. Let me just open. So once you open it, you click through like the options, just like default options, target, open browser. And they'll open up like its own little Chromium browser. So let me just copy and paste this. That's fine. Okay. I want to say, by default, this intercept will be on. So let me just demonstrate what it looks like with default settings. When you go to any web page, sometimes it's a little annoying, and you can set options for it to like intercept at less web pages. But by default, what Burp Suite does is every web request you send out to going out to a web server or coming back from web server, it'll sit between and say, "Hi, I just picked up this interesting traffic. Do you want Burp to receive it, and do you want to officially receive it, or do you want to just pretend you didn't receive it?" In this case, I'm just gonna receive it normally. Forward. And once you hit the forward, you see that the web page loads. So I'm going to just at test.com test. And then now that I've made the request, you can see that something is going out. Something has been intercepted going out. Actually, can everyone see this properly, or would they like zoom in a little more? I'm gonna zoom. I don't know if Control Plus works. Okay. Let's use our. That's the search. That's not. Desperate times call for desperate measures. Is this any better for those of you sitting in the back? Okay, I will try and navigate around. But so what I did was I issued the login request, and then Burp said, "Hey, something's going out. Let me pick that up." And I can see that I have a request. It has the payload data. It has a bunch of, the headers over here. I want to modify that. Let's see if I can remember, think it was this one. if you set a header called xdev access yes, I'll be able to log in as whatever. Okay. In order to change that request, I'm gonna have to do a little send to intruder. Intruder is the tool that allows you to like modify requests and send them on. Now I want to say, what's it? Xdev access yes. Now that I've modified, I want to send it on, so I say oops. Send intruder. I think I might be able to just do it from here, so it can just be like access yes. Then now that I've modified it, forward it up. Invalid credentials. I think it might only work for that email they provided us, so actually I'm sorry. ctf.org, and I want to, okay, let's try it again. Boom, test, login. I've intercepted requests. I'm going to change it live. Make sure I get it correct. This one. Okay, it's made. Forward. Login successful. There we go. We got it. There's the flag. Being able to change web requests live is will be a good thing to use. The ability to do it is pretty important to web penetration testing. So that's how you do it. You can do it burp. Of course, if you just want to build your own API requests, you can use, I know I had a tool, let's see, Postman. Yeah, there are other tools that are not cybersecurity focused. This is more like developer focused that you can send custom requests to an API for. Postman, I think I used it in the past. You will need to make an account. You can use it, or you can use something like curl, which is literally a command for just building. It just runs HTTP requests. So figure out what terminal. So let me just spin it up again. Track the gates. Launch instance. I think I just run curl. I can just run command line tool. The graphical one's much easier, but curl can run this. It'll give you HTML code, but there's also, let me just do man curl. I'm not going to go into exactly how to build it because I think there's easier ways to do it, but there's a bunch of options saying, oh, curl, include this custom header, include this payload, send it to this URL and do whatever. Curl is just a command line way of doing the exact same things I've just done. Build your own request, but it's just a command line as opposed to a GUI interface. Okay, any questions about that? All right, 250. Let's see, burp. Cover that. Adder. You know what? I'll cover it. Okay, and this one appropriately named is quote intro to burp. Is a lot more burp focused. And then I can just say, okay, let's pass it into our best friend burp and see what's going on. I guess just easy way to limit it. This burp is fine if you're doing limited stuff, but say I want to use this browser to go to like google.com or I think I have I already have it configured. There's a little tab under target that's called scope. You can say, I don't want burp to ever intercept requests going to Google because I'm just looking stuff up and it's really annoying to have to click accept forward all requests that are just stuff I want to see. Instead, just like, oh, only target these, only intercept requests coming from these URLs, these subdomains. You can limit it so burp intercepts less. So that's a quality of life feature if you would like it. I think you can, I think scope, you can just add like say, oh, match. Oh, you can exclude, you can include, etc., etc. Okay. All right. In the meantime, I'm just going to use the plain old DevTools just to figure out what's going on and see if I can get away. In this case, give me a name.
Jack.
Jack. Jack. 4. 2. 1, 2, 3, 4, 5, 6. Register. What? What's going on here? 2FA authentication, and there's nothing telling me what I need to. Oh, well, man. Okay. All right. That's all right. Challenge over. It's over. I give up. No. Okay. Let's see what's going on in the network request to see what is going on when I hit register. Okay, it's making a post request. I can just look at request that was made. Let me just look at the raw one. Response cookies. I mean, there's like a session cookie, HTTP only. Request. I mean, it's not going to show it in the in like the plain text format, but this is just a request. Let me raw. Okay, that's very ugly to read. I'm just going to read it normally. Okay, it's just sending data, whatever. 2FA. What if I? Okay, submits, and then it's sent OTP. What's going on here? Request headers. Is there any way to skip this one time? Because this is really annoying. Very set cookie request user agent. If I submit it, let's see. Found. Okay, whatever. Content do not track. Okay, it just sends the data again. You know what? Let's just pop it into burp and just intercept the packets and see what's going on because it's going by way too fast for me to do it. Okay. Never. Let me add this to the scope because it seems like it's not being intercepted. Proxy intercept. Oh, I turned it off. That's why. That's goofy. Register. Okay. Post. Okay, this is much easier to read. I can see have a bunch of data. Here's a token. CSRF token you can usually ignore. CSRF is, oh man, what cross-site request CSRF? Some kind of, it's a web security feature that just like default, you can ignore it. It's usually not part of the challenge. Cross-site request forgery. Yeah, it's usually, if you're doing some kind of challenge, it's usually not relevant because it's inserted by the browser itself to keep you secure. Okay. Okay. Forward it. Getting something back. Get dashboard. Okay. I'm going to some kind of dashboard. And at this dashboard, I have to enter the one-time code. This one-time code. Just check the hints real quick. Because hints are free. Intercept. Try mangling the request. Maybe their server-side code doesn't handle malformed requests very well. This one-time code is this OTP is annoying me. What if I just deleted it and forwarded it? Something's happening. Something's happening. Give me a second. I believe the solution is just if you remove the one-time code, it just explodes the server, and then you'll be able to get the flag that way. Refer back to FA. Send registration page. Okay, yes. Invalid. Removing from the request body. Did we get anything back? Post. Yes. Did it not? Original request. Target history. Okay, I don't know why it's not working this time. There goes my streak of unscuffed demos. But the solution was if you just remove the one-time code, it would return something, error out. It would error a little, but return a request that had the flag in the in response. Okay, that's kind of goofy. I will try and figure it out for the next one. Okay. Skill. Okay. Last kind of tool that is good, I guess because we're running out of time, I'll demonstrate next time, is what's called a brute forcer. Has anyone here heard of robots.txt? Sound very familiar? It's kind of a hidden page on websites that say, oh, web crawlers, please don't crawl this specific domain because there's like either sensitive stuff on it or we don't want someone spamming the page. So let me... Well, I'll just use like live one. Robots of text. So I mean, what does UC Davis not want the web crawl engines want? They don't want you looking at profiles. Ooh, core, admin, node, user, register. Yeah, they don't want like random web crawlers trying to log into pages and whatnot. That's one way of making a web page not appear on search engines, but it doesn't mean they're not reachable. So I'm gonna do a little trolling. User register. I don't think this should. I think okay, yeah, 403. I can't log into the UC Davis website and I don't know, do funny things. But just the point is, just because a website isn't findable on a search engine doesn't mean it's not there. A lot of websites, they might be like, oh, we're not gonna publicly disclose that there's a page here, but if they name it something like loginpage.php, you can probably go to it, even if they don't disclose it. So you can use a tool, Durbuster, GoBuster, FFUF. These are kind of tools that say, okay, give me a word list. I'm going to try all of these URLs, at, say, ucdavis.edu. I'm going to try login.html, login.php, login. I'm going to try and go to all of these web pages in hope of discovering something that was hidden. I'll do a live demonstration next time, but the warning is do brute force with care. Please brute force with care, because think about it. Let me try going this page 10,000 times for every single one of these possible places on a word list. That generates a lot of traffic. One, it's noisy. Two, it is literally one step removed from a DDoS attack. It is an easy way of getting like IP blocked. It's not illegal, but it's like the kind of stuff it's like someone will complain to you about, and it's kind of the attention you don't want. So if stay in scope, we're allowed to do this for like assignments and maybe on pages like If I Hack Me, Pico CTF. I would say like don't try brute forcing against them, but brute force with care and stay in scope, because you're pretty much generating a DDoS attack against a web server. Okay, I'll demonstrate the rest next time. Thank you, everyone.